Good morning, everyone, or I don't know, almost good afternoon here. Thanks for joining this presentation on what SAP is doing in the big data and Hadoop space. First of all, introducing me. Well, I can speak in French if there is a French crowd. We're in Belgium, so again, well, Bruxelles is almost neutral. So my name is Javier Cuerva. I've been working for SAP for the past 20 years. So I've been there for quite some time. And I do work in what we call the global COE, the Center of Expertise, and I'm a technical solution architect, basically building solutions around in the SAP portfolio and working on big data subjects, as a matter of fact. So the goal of this presentation is, you may be thinking, well, SAP, what SAP is doing here? Normally SAP is known for its, ERPs and CRM and, enterprise applications. And, this is a Hadoop conference. So what's the deal here? It happens to be that we have a very strong big data strategy. And the goal of this presentation is to go through that, obviously talk about, our platform, and also, mention what we're doing in the big data Hadoop space, the integration between the HANA platform and Hadoop, what we've done so far and where we're going in the months to come. I'll give you a preview of what the roadmap is going to be. So that's the plan for today. All right. If you have any questions, please let me know, and we can take them either after during the 10 minutes Q&A that is allocated during the presentation, or if there is a burning desire for you to ask something and you can't resist the end of the presentation, please let me know as well. I'm flexible. So should I click next? There you go. So obviously we're in a big data conference, in a Hadoop conference, and the couple of slides that I'm going to present are pretty much all known. We're talking about big data. Yesterday I was in a conference. I was in one of the keynotes, and there was a guy from Forrester saying, there is a big data explosion because not only because we've got devices with us, mobile devices that do have an IP that can generate data. There is also what they call healthcare data, and these Fitbits and smart devices that can control the number of steps you do during the day, the exercise that you do, the type of food that you eat, and then come up with recommendation in order to have a better health. Also, obviously, we at SAP are living in we do control a big data state due to the fact that we have very large customers, extremely large enterprise customers that are generating more and more data, and normally this data is living in relational data stores, the SAP HANA data platform, the SAP ASC database, SAP IQ database, or others. So obviously there is quite a lot of data there, and much of it is structured because it's living in a relational database. Okay, but this is not only that. Most of the data as well is we have customers that do have industrial equipments, and for instance they want to do predictive maintenance, so they have their tractors equipped with sensors, and they do generate quite a lot of data that you have to store, that you have to analyze, and obviously run predictive algorithms on top of it in order to basically do something with that data. Obviously weblogs, that tells you what type of items you surf, or what type of if you are in an online retailer, what type of objects you are going to purchase, what type of object you should be able to purchase based upon your history. So obviously we have a data explosion, and the social media, the social networks, the Twitters, the Facebooks of this world are adding more and more volume to this. As a matter of fact, I've got here some quotes from IDC, where until 2020 the digital universe will double every 2 years, reaching 40 zettabytes. And for your information, a zettabyte is like 1 million petabytes. So this is getting to be worse and worse in terms of data management and so on. So until now, next, there we go. So until now, most of this data obviously was not really valuable because we didn't have either the hardware for that. Now with the commodity hardware, you can store more and more. And with the advance of the Hadoop ecosystem, you can as well exploit that data. Yesterday, somebody from Microsoft was saying, well, we're doing something with in order to treat the cancer. This is a common use case because we're doing exactly the same with another customer where we are basically taking medical information of patients that do have cancer, and we are basically shortening the number of cycles that a doctor needs in order to basically recommend the good medicine or the good treatment for that person that is having or needs cancer treatment. So obviously there is a big impact on healthcare, and again, I am quoting IDC and McKinsey that have done quite a lot of study on how these big data is, what the big data economics, how this data that was before not really valuable, how can we turn value out of it? Okay, so as well, if we talk about network providers or service providers, they are living in a gold mine because there is more and more traffic generated by mobile devices, and obviously they want to well, they have a lot of data and they can use that data in order to do real-time promotions or things like that. And now with smart devices that can tell you where you are located at any point in time, so they have dual 2D double dimension type of information where you are, and they can recommend on in real time what type of a restaurant you would like based upon the history you have. So obviously in the manufacturing also vertical, we are working with a lot of customers, and one is a tire provider that has basically changed his model and put sensors on the tires so that they can do predictive analytics on what type of if a tire should be changed, the type of conduction or driving that you are that you do if you are very aggressive, and things like that. So obviously they are changing their model from basically selling tires to going up in the chain and being able to to exploit that data and generate business out of it. So that's the context. So what do we do at SAP in terms of big data management? So at SAP we have a platform that was launched like 5 years ago called the HANA Data Platform. So initially that was a database basically focusing on the OLAP, analytics type of workloads. And I'm saying here it's not a platform anymore, but it's not a database anymore, but a platform in the sense that we've extended the different type of use cases we can do with HANA. HANA is an in-memory database. So you're going to say, well, everybody does in-memory as of today. Well, not the same way that we do. We do in-memory for not only OLAP type of queries, but also OLTP type of workloads. And when we talk about a platform, we mean by platform the capability to do not only OLTP and OLAP type of workloads, but also to be able to ingest massive amounts of data, streaming data, for instance. We have the capability to do text analytics on the platform, and this is a scale-up and also a scale-out type of architecture. So you can start with one node and grow your architecture by scaling out and adding nodes to your cluster. So that's a cluster-oriented type of data management tool. So it does. You have different type of layers such as ingestion. So you can ingest data coming from relational databases, from Twitter feeds. So we have extended the platform with what we call smart data integration that allows you to basically federate data coming from any type of source, either relational, obviously, but also non-relational and completely unstructured, such as Twitter feeds or whatever you like. Okay. So the storage as in itself is an in-memory database, obviously, and column-oriented, because we think that in order to do big data analytics, what you need is the old recipe of having row-oriented database do not work. So we took the problem and decided to move to a column-oriented database. That is the secret recipe in order to have extremely fast results on OLAP type of queries, but also being able to do OLTP on a column-oriented database. Okay, so we provide what we call an end-to-end solution in the sense that it's not just a platform, it's not just a data management platform, but there is an ecosystem all around that allows you to have BI and visualization tools to access big data volumes, and most of these applications on top are also capable to access a Hadoop distribution. So we have a very strong a relationship with Hortonworks. We work with them on a daily basis, and the platform itself is integrated with Hortonworks, but it's completely agnostic and can work as well with our distributions. So I'm not going to call every single feature that you see here about what HANA is doing in terms of big data management, but some of them. So for instance, I can talk about this one, which is in the middle, called replication server and real-time data movement to Hadoop, because this is something that I wrote last year. The idea here is what we've heard from our colleagues from Hortonworks is that they want to build these big data lakes in order to have in one spot data coming from different type of environments, either relational databases, in order to build the next big EDW. Okay, so obviously when I come with that idea last year, within SAP we've got an enterprise class data movement tool called Rep Server that allows you to replicate transactions to normally a database. So it's a transactional data movement piece or data movement product. But if you want to be a good citizen in the Hadoop world, what you need is to be able to to move data real time into, and not in batch time or batch fashion, in a Hadoop data lake. So Rep Server was extended last year in order to be certified and being able to replicate data from any relational data store, well, the big ones we'll say, into Hive. All right, we have another extension that allows you to use Rep Server and to replicate data into HDFS as well. So you can have a data lake that is, in real time, updated, instead of taking files and uploading them and doing some treatment on them or some, ETL, ELT type of job. Another topic I want to call here is what we call data services. Obviously, data services is again an enterprise tool in order to do ETL or data management, or EIM, enterprise information management. And we've been adding different type of capabilities during in the last releases in order to be able to call Hive jobs, call MapReduce jobs as well, integrate with the HDFS and also other document type oriented databases such as MongoDB and Cassandra. Okay, so obviously we can generate data or we can import data from those stores into our platform, or vice versa. We can also, in a case of a Hadoop ecosystem, call invoke MapReduce jobs, take the results, import them into the HANA platform, for instance. All right. One of the features as well that I'm going to talk about here is what we call the Data Warehouse Foundation. This is a series of tools that we are going to produce this year in order to move data from HANA into Hadoop. Because one of the use cases that a lot of customers are combining our platform with Hadoop is a very simple use case, which is the data has a value when it's fresh. The longer the data is, or the older the data is, the less value it has. So obviously when we talk about an in-memory database, storing things in memory, okay, between quotes, does have a cost. So obviously there is the value of the data during the time is going less and less, so it has less and less value, but it needs to be accessible. And one of the use cases that a lot of customers are asking us is, okay, I want to offload data from my primary database into a Hadoop, a data lake. How can I do that? It doesn't have to be real time, so it doesn't apply for real-time data movement with web server. But from time to time, I want to offload the data, but still being accessible. So the data warehouse foundation is basically adding intelligence on top of Hadoop to let you define customers, agent rules in order to move data from the hot in-memory space into what we'll call a colder space. All those still available. We're not talking about archiving into a tape, but archiving into Hadoop store where it can be accessible, for instance, via Hive or via MapReduce or via HDFS, for instance. Okay, so these are one of the other components that we are going to provide to our customers, and some of the features that are on the top, such as Smart Data Access, that allows you to federate any data into the HANA platform. So yesterday there was a presentation from Forrester as well that was there, and he was mentioning, SQL on Hadoop is a big trend, and obviously we are playing in that space. So we understand that SQL is a de facto language. Okay, users do know SQL normally, or let me take it that way. I was with a customer last week and said, well, listen, my business analysts do know SQL. They don't know Scala, they don't know Java, they don't have programming skills, but I want to provide them a tool, or at least a way to access data that is offloaded into a Hadoop lake, but using SQL. Okay, so SQL on Hadoop. So there are different type of solutions. Obviously, pure SQL on Hadoop solutions, such as Hive and Impala and Drail and Tahoe and those. And we are, if you remember the slide from the Forrester guy yesterday, there was one called Federation, which is we have a store, and that store can be can fetch or access data that is living either in another relational store or within a Hadoop Hive data lake. So that's what we're providing. And there was a third one, which was basically a big data appliance, having Hadoop nodes and different type of data management solutions. We are playing in the middle one, which is being able to extend the data that you can access by these smart data access to define, to be able to access remote sources as what we call virtual tables. So for you, as a SQL developer or SQL, oriented person, you will create what we call a virtual table, which is nothing more than a proxy to something that is living remotely, and that table can be combined with regular tables, column-oriented tables that we have in our platform, and you can do joins between them and fetch data from Hive, in that case, into HANA. There is another one which is pretty impressive, and we haven't done quite a lot of marketing around it, called the Smart Data Integration that you see at the bottom left. So obviously we can't certify every single SQL on Hadoop engines that are available on the market. So we are integrating with Hive, with Impala, with the big ones. But in the Hadoop ecosystem, there is quite a lot of. It's very dynamic. So every single quarter there is like a new initiative. Tahoe, Drail from Mapar and those guys. So it's hard for us to cope with all these servers or data management solutions that are available. So as a matter of fact, what we provide now with Smart Data Integration is the capability for you to integrate with whatever you want. So we provide you an API, and this API you can program it. It's a series of Java functions, Java classes that you need to implement, and you can extend the HANA data platform with any type of store, either relational or non-relational. So for instance, one of the exercises that I have on my plate is how from HANA you can integrate with the HBase, for instance, all right, which is not relational, it's a key value pair, but you can do this type of integration if need be. So real-time, in-memory, and something which is real-time also in the Hadoop ecosystem. So that's really a tool, a set of APIs that you can use at your leisure in order to extend the value of or the data that can be analyzed by HANA. All right. I will call out some of the other technologies later on in my presentation. So this is what we call the HANA Data Platform for Big Data. So obviously, it's a comprehensive, holistic, solution where we have, well, this should be drawn here. I don't know. There is something going on with that's a PPT on Mac. So we've got an infinite site that should be in the middle. So when we talk about data, big data, normally we talk about velocity of the data, the value, the variety of the data, and also the volumes of the data. And with the platform, we have the capability to fulfill all these three V's or features. We can do what we call we can fulfill the three V's by the sense that when you have you have a lot of information that is generated and you want to capture that, there is what we call HANA big data native type of features, and we have also the integration with Hadoop that I'm going to mention in a short while. So basically, a platform that is combining three different stores, but having a same unique type of experience. So, for instance, between SAP HANA in-memory database and the HANA dynamic tiering, which is a solution that allows you to manage structured data, but on disk, because as I said before, being able to handle all the data in memory has a cost, obviously. So, if you have structured data, that data can, as time passes by or flies, the value is less, but you want still to have access to that in a structured way. So that's the reason why we've coupled an engine which is called the HANA Dynamic Tiering, which basically is something. It's a column-oriented database that we inherited from the Sybase acquisition, if you are familiar with databases and relational data stores. But the idea or the integration between those two is completely, is total in the sense that we provide you one single experience in terms of data management. So that means that if I've got data in my in-memory store, and I want and data in my warm data store, I've got the capability to basically, run backups and restores from HANA, and they will spawn against the HANA dynamic tiering as well. So common experience in the sense of installation, in the sense of backup and restore, in the sense that it's also, the two engines are completely integrated in the sense that you have one common administration and monitoring experience as well. So if we talk about what we do in the big data space in a native fashion, and so that's what we call native big data. We have different type of features such as dynamic tiering that I just mentioned right now, and I'm going to give you a sample of what it is. And also for streaming data, we have a completely integrated engine as well, which is called the Smart Data Streaming. So you can see the platform as a series of services, and being able to instantiate one of them depending on the use case that you have. So dynamic tiering is what we call big data analytics or big data storage on structured data. Smart data streaming is basically the capability to have a streaming engine completely incorporated and integrated within the platform that allows you to capture either data from streaming engines or coming from different type of queues, JMSs, different type of buses, and have also one single experience, because those are services that are available within the engine. We have also other, for big data native type of problems, the capability to have geolocation as well within the engine. So you can run queries on rectangles or points, or you need to have you need to know how many users are roaming within this polygon, which is typically a geolocation type of query. So we have those services completely native. On the HANA and Hadoop interface, what do we do? So we have integration with Hive and Spark, and recently what we've done is to extend the HANA capabilities in order to do native MapReduce calls, and also to be able to access any HDFS content. So that means being able to federate data from those environments into HANA as well. So if we talk about dynamic tiering for a little while, so as I said, this is a big data native solution for mainly structure type of data, where you have here on the right-hand side of the picture what we call the index server, which is basically the in-memory space or the in-memory location where data is. And what we've done is to extend via these green box here, which is called dynamic tiering or extended engine or extended storage, the capability to have tables created in that space using this syntax. And you're going to say, well, this is exactly the same syntax you would be using to create a table in any database. And that's that's the goal of it. You want to have the same SQL experience that you may have with a regular database, and extend that using these primitives here, the capability to access a table that is living in this space. Okay, so this is as well a column-oriented database, but has a capability to do it's column-oriented, but it's on disk. So you can store massive amounts of data, from terabytes to petabytes. And as I mentioned before, this is what we call a single database experience in terms of installation and monitoring, administration, backup and restore. And the SQL experience is basically the same you would have with a regular database. On the Hadoop integration space, what are we doing? So we are now in SPS 9, which is the latest and greatest version that we provide with HANA. And during the different type of iteration, we've added more and more features in order to support Hadoop. So the first one was the capability to call Hive or Hive tables using what we call SDA or Smart Data Access, which is, as I mentioned before, the capability to access remote table as if they were local. And the data is basically shipped in real time. So every time you run a select statement against that proxy table, the data is brought within the in-memory engine at the time. So it's so there is, well, you can copy the data in if you want in order to avoid a backup, network data movement. So the first integration, the first step was Hive integration. And what we've done recently is to have the capability to invoke MapReduce jobs and also HDFS files. And the Spark SQL integration is basically as well in the product because it's using the same SDA type of capability. So feature highlights. So this is basically one of the, in a nutshell, what we're providing with Hive integration, which is first of all the capability to define what we call a remote server, which basically points HANA to a Hive installation. Second of all, once you have created your remote source, you can basically introspect what type of tables are available there and add them as a virtual table. And once you've done that, basically that virtual table is nothing more than a regular table. So you can combine, for instance, you see here, a regular table that is living in the in-memory space and join that with a Hive table on these column, for instance, right? So this is what we call data federation. You see here the results. What we've done as well in SPS 7 is to add what we call caching capabilities, because in the end, if you have quite a lot of concurrent users running the same type of query, what you don't want to do is to invoke the MapReduce job every time. So there is a feature within the product called remote caching that basically is materializing the results out of a query, for instance this one, as an HDFS file in the Hadoop cluster, so that the next time the same query gets in or is executed, instead of running through a lengthy MapReduce job, we can just basically grab the HDFS file and upload that into memory and give that answer to the customer or to the user. So that's what we call instant Hive execution. So this is available for Hive, and one of the hints is use remote cache that you see here. So it's pretty simple. So what the architecture for HDFS and MapReduce integration, what it is. So this is a high-level architecture, and what we've done is to extend HANA with the capability to invoke web HDFS in order to run, web HDFS REST API in order to access HDFS files, and also web HCAT in order to get, all the data types, primitive metadata of the data living in the Hadoop cluster. So we have what we call a proxy here, or a client that is basically doing calls to web HDFS and web HCAT. That's in a nutshell the architecture, and this is living, as you can see, in the index server down there. So for the guys that are very techy, just put the syntax on that, and whatever the integration with either with HDFS or MapReduce, it's done what we call with a virtual function. So a virtual function is basically a name, a UDF, a user-defined function that obviously returns a result set of what either the HDFS call or the MapReduce call is going to return, and then you have different type of configuration parameters. And the @remote server name is basically pointing where is your Hadoop cluster located. So where is the location of a Templeton, which is WebHCAT, and where is the location of the WebHDFS URL and port in order for me to run that query against. Okay, so once you've done that, which is basically a DDL, you are able to invoke that virtual function in place where a table or derived table can be positioned within a SQL statement. As simple as that. So that's again the same experience, the same SQL experience that customers are asking. Okay, so some of the highlights for HDFS integration. Obviously, this is read-only, so we can read at this time HDFS files and return them as result set. So if you are interested on some of the features, I've listed them here. Basically, the most important is the HDFS location. Where is the HDFS file located? The different type of delimiters you have in the file, and then some of the format, some of the formats, some of the options in order to format a date or date time or time. So that's one of the features here that you have here in order to do HDFS calls. There you go. I do have a demo here in order for you to see and do not do too much of slideware. So I have to move that to the second screen. Yes? Okay. So can you do that quickly? All right. So I don't know if you see, well, the guys at the back of the room maybe do not see that, but basically this demo is telling you how you can invoke an HDFS file. So you see in the first line, create remote source. The adapter is Hadoop, and then you just basically point to the URL, which is the WebHDFS URL and the WebHCAT URL, using the password call Hive and password Hive. So as of today, this is basically user and password enabled. So once you have that, you can see on the left side of the screen that you have a new server that is available for you to access via what we call a second part, the virtual function. Okay, so the virtual function is defined here. It's basically using the same syntax that you see before, and it basically tells you what is the result set of the function, or what is this HDFS file going to return. So you have to define what we call the result set, the different type of delimiters, and then that function is capable to be executed within a SQL statement the same way a regular table could be executed. All right? Okay, can we flip back to the screen, to the PPT? So this is basically the way to do it. And then you can see here the select statements, which are basically regular SQL statements. Okay? Thank you. So that is the demo will be provided on the Hadoop Hadoop site, so you can download them and read them and watch them at your leisure. So for MapReduce integration, that's basically using the same feature, but here what we do provide is what we call a unified data developer experience. So one of the tools that we use for development within HANA, it's called the HANA Studio, which is a series of plugins on top of Eclipse. All right. So the idea here is, if I am a Java developer, do I need to go to Eclipse or to IntelliJ or one of those tools in order to create my my Java classes, my mappers and reducers? You can still, you don't have to switch environments. Basically, what we do provide is the capability for you to develop your MapReduce jobs and being able to deploy them from HANA as well. Okay, so that's what we call an end-to-end development. You can write your code and you can deploy your code from HANA Studio into the Hadoop cluster as well. So one of the one of the features that you see here is where is my mapper, where is my reducer, and where is my input, my series of input files for my map and reduce job to kick in. Okay, so I'm gonna skip on the video, and that's pretty much what we are providing as of today. So where are we heading in terms of support for you know, the integration between HANA data platform and Hadoop? So this is a list of, you know, features that we are working on at this time. So one that I would like to call out is you know, the integration with Ambari. So as of today, if you have a HANA cluster, you know, several types of machines, you have a Hadoop cluster, you know, how do you have a common experience in terms of administration and monitoring? You have to go to Ambari for one thing. You have to go to what we call the SAP HANA cockpit, which is as well an HTML5 you know, presentation layer, but you are switching from one environment to the other. So the idea is to have what we call a tile within the HANA cockpit in order from that tile or from that, you know, widget, being able to click on that and access the different type of Ambari views from the same cockpit, you know, monitoring tool. So integration between the two is something that is going to be provided by the end of in SPS 10, which is the next release, by the end of Q2 normally. Some other features we are working on is having a very fast and lightweight replication data movement tool between HANA and Hadoop, which is based upon the technology that I mentioned before that I worked on, you know, last year. But we're going to extend that also into HANA, so move data based upon different type of rules from, you know, the hot in-memory space into an archive in Hadoop. Provide better, we'll say, integration on security, and as of today, you've seen in the screenshot, it's basically user and password driven. We are working on the integration with Ranger in order to have a common security experience between the HANA credentials and the Hadoop credentials, and obviously do some integration on top of, you know, SAP and Spark SQL. We are also working on other projects, such as, for instance, what I mentioned before, the data aging solution for HANA data lifecycle, which is to define rules for archiving, not in real time, but basically you know, batch-based. All right. So, in a conclusion, what I would like to do is basically provide you a one single, you know, slide idea where what we provide with the SAP HANA data platform is one platform to be able to do to be able to manage any type of workloads. So not only OLAP, but OLTP, and also being able to access Hadoop data. What we provide is an integrated platform in the sense that what we want to provide, or we provide as well as of today, is a single integrated database experience. So you don't have to worry about, you know, the different type of engines within the behind the scenes, because everything is pretty much integrated, and as a matter of fact, we were talking about security a second ago. So integrated in the sense of security, but also management, backup and restore. Also open, we are following and implementing open standards. So you have the capability to access the HANA platform using any type of driver such as JDBC, ADO.NET, ODBC, OData. So very open platform in order to provide our customers with the the maximum of choices for them to develop on top of HANA. So that's my conclusions. If you have any question on this presentation, please feel free to ask. No questions? So I am 10 seconds. All right, go ahead.
You presented different capabilities to access Hadoop from HANA.
Yes.
The big advantage in HANA is in memory,
Mm-hmm.
so very fast.
Mm-hmm.
So can you give some indications about performance impact, if or experience already, if you select data in different ways from HANA, from Hadoop,
Well, it really depends on the use cases, because that's the reason why we have like several type of solutions as of today. So, when we are talking about Hive integration, we are basically talking about, SQL semantics, because that's a SQL layer on top of, that allows you to do run SQL queries on top of, MapReduce jobs. Obviously, you are really constrained by the SQL semantics that Hive provides you. So that's the reason why we are seeing, or we have implemented these MapReduce and HDFS integration as well. In terms of performance, it really depends on the volumes of the data, because in the end, normally what you have between the two is a network connection. So the faster the network connection is, the better performance you will have. So it really depends on the type of volumes that are going to be brought within the HANA engine. What we've done is to be able to extend these SDA capability in order to add what we call intelligence to it. So depending on the query, the HANA optimizer is smart enough in order to basically see what aggregates can be pushed down into the Hive layer, so that what we don't want is to bring the whole data set into in-memory and then process the result set with the joins or other tables in memory. So what we've done is to add intelligence to the optimizer and see, depending on the statistics that are available on the remote source, being able to either push down or sometimes reverse a query and being able to execute part of it into the remote source and just bring back what is relevant to the query. All right. Any other questions? 1, 2, 3. Thank you for your time.